Next, we are going to take a look at the derivative of a function at any point. So here we are going to look, or we are going to focus specifically on any point where x can be equals to a and a can take any value. So if you take a look at your notes, it was mentioned there that the derivative of a function at point x is equal to a is defined as, and you are given the formula. So where do we get that formula? If you recall, the formula for first principle is f prime x is equal to the limit of fx plus h minus f of x divided by h as h approaches 0. So if you realize now, we are going to substitute x is equal to a regardless of whatever the limit of h there. So we are going to substitute a here and here as well. And that will give us the formula as shown in the notes, where f prime of a, because we substitute x is equal to a, is actually equal to the limit of f a plus h minus f of a divided by h as h approaches 0. So what we are going to do here is, we don't want to have the formula that is looking very complicated there. So we are going to take h is actually equal to x minus a. Okay, so from here, we can just substitute all those h with x minus a, and then the formula will be simplified into f prime a is equal to the limit of fx minus f of a divided by x minus a as x approaches a. So this is the formula, the final form of formula that we are going to use. Okay. And now let's take a look at the example. For example 2a, you are asked to find the derivative of fx at the given point, where in the first example, question a, you are given f of x is equal to 3x squared plus 12, and you need to find the derivative at the given point, where the point that we want is a is equal to 2. So we just need to use the formula that we just see, the one that I highlighted in pink. So the formula says f prime of a is equal to the limit of fx minus f of a divided by x minus a as x approaches a. So here x will approach the value 2. And now how do we start? First, you can write your formula, but since I have my formula up there, I'm not going to write it again here. So the first thing you need to find is find f of a, where here a is 2, so I need to find f of 2. So substitute x is equal to 2 will give you 3 times 2 squared plus 12. And if you simplify that, you are going to get the answer is 24. And then we are going to just plug everything in to the formula, and I will have f prime of 2 is actually equals to the limit of fx minus fa, which is f2 is 24, divided by x minus 2 as x approaches to 2. And you can just substitute fx. You will have here the limit of 3x squared plus 12 minus 24 divided by x minus 2 as x approaches to 2. So we can simplify, and that will give me the limit of 3x squared minus 12 divided by x minus 2 as x approaches to 2. And if you take note here, we have similar factor there. I can factorize 3 out. And you can also see now, after I factorize 3, what's left inside is x squared minus 4, and we can use the formula a squared minus b squared is actually equals to a minus b times a plus b. So I can rewrite that as the limit of 3 times x plus 2 times x minus 2 divided by x minus 2 as x approaches to 2. And if you see, we can simplify this. That will become 1. And then we are going to have the limit of 3 times x plus 2 as x approaches to 2. And now we are going to substitute the value x is equal to 2. So once we substitute, then the limit will disappear. We will have 3 times 2 plus 2, and the answer will be 12. So f prime of 2 is equal to 12. Next, we are going to take a look at example 3, where you are asked to determine whether the fx is differentiable at x is equal to 1. So now I'm going to write my formula to find the derivative at a point here, because I can't see the formula on screen anymore. So if you recall, our formula is f prime of a is actually equals to the limit of fx minus f of a divided by x minus a as x approaches to a. So in this question, what does it mean by differentiable at x is equal to 1? So since we are going to use the concept limit here, and if you recall, from last chapter, we learned already untuk check limit dari kiri dan dari kanan. So now if it is differentiable at x is equal to 1, so kita akan check limit dari kiri dan dari kanan menggunakan formula f prime a ini dan nilainya sepatutnya dapat sama. So now what we are going to do is we will check the limit of fx minus f of a divided by x minus a as x approaches a from the left, and you also need to check the limit of fx minus f of a divided by x minus a as x approaches a from the right. Jadi macam biasalah, kalau anda selesa menggunakan garis nombor dan buat garis nombor, pemisahnya adalah 1 di sini dan sebelah kiri fungsinya adalah x kuasa 2, sebelah kanan fungsinya x tambah 1. And then we are going to just substitute kat sini. Tapi kalau awak take note di sini guna ink warna biru, saya akan kira dahulu di tepi ini f of a. Untuk fungsi yang atas, apabila saya cari f1, jawapannya adalah 1 kuasa 2 tetap 1. Untuk yang bawah, kalau saya cari f1 dan jawapannya adalah 2. Okay. So what we are going to do here, we are going to put those values and function ke dalam kita punya apa yang kita nak cari. So saya nak cari now limit of fx. Fx saya untuk x yang menghampiri 1 dari sebelah kiri. So 1 dari sebelah kiri fungsinya adalah x kuasa 2, tolakkan fa, saya dah kira nilainya adalah 1 and then dibahagikan dengan x tolak a, x tolak 1. Okay, so x menghampiri 1 dari kiri. Jadi di sini apa yang kita akan dapat, kalau awak tengok tak boleh buat apa-apa. Kalau awak substitute 1 terus, dia akan bagi IDF sebab 0 per 0. So we are going to factorize whatever on the numerator and saya akan dapat di situ limit of x tambah 1 darab x tolak 1 dibahagikan dengan x tolak 1 apabila x menghampiri 1 dari kiri. And we can cancel out x minus 1. So that leaves me with the limit of x plus 1 as x approaches 1 from the left. Jadi saya akan dapat jawapan di sini adalah 2. Okay, now let's take a look at the second part. Saya perlu cari limit daripada sebelah kanan pula. So di sini again a saya nilainya adalah 1. Jadi kita substitute fx dan fa. Saya nak cari limit fx untuk kawasan yang datang dari sebelah kanan 1. So fungsinya adalah x plus 1 minus f1 saya adalah 2 dibahagikan dengan x tolak 1 as x approaches 1 from the right. So kalau simplify yang atas itu, kita akan dapat limit of x minus 1 over x minus 1 as x approaches 1 from the right. Jadi again, kita simplify sebab kalau substitute 1 pun dapat IDF. So you get the limit of 1 as x approaches 1 from the right. Jawapannya tetap 1. So for the conclusion, because we need to know if fx is differentiable at x is equal to 1, kita just perlu compare limit. Okay, kita akan ambil limit of fx when x approaches 1 from the left, nilainya tidak sama dengan limit of fx apabila x approaches 1 from the right. Kenapa? Sebab kita dapat tadi sebelah kiri 2, sebelah kanan nilainya 1. So dari situ terus buat conclusion fx is not differentiable at x is equal to 1. Okay. So thank you and I hope you can complete all the examples. If you cannot, please refer to me back. Okay.